download Python source files, we assume that you have installed Python on your computer. For example, an Anaconda distribution, and using an IDE such as PyCharm, Spider, VS Code. String variables. Every variable holds a value, which is the information assigned and associated with that variable. You can change the value of a variable in your program at any time. So strings. A string is simply a series of characters. Anything inside quotes is considered a string in Python, and you can use single or double quotes around your strings like this. So this is a string inside double quotes, and this is also a string inside single quotes, but there are also double quotes inside the single quotes. So this is a string message, and we can print this string hello Python world, and this is also a string. We can also print and changing case in a string with methods. So this is a string with all lowercase alphabet. Then you can print name.title, so each word begins with a capital letter. Name is a string. If we show all alphabets are lowercase, then we can print this string but with the title method after this string. So A, Ada, Lovelace. So these two alphabets will be uppercase. Can also print a name dot up. So all alphabets will be uppercase. Or name dot lower, then all alphabets will be lowercase. So we create string name again. We show name as title case. So we can print with uppercase. All alphabets are uppercase now. And now all alphabets are lowercase. Combining or concatenating strings. So this is a string first name, and this is a string for last name. So you can create a string called full name using first name plus a space symbol and with last name. Then you can print out. So first name Ada, last name is Lovelace. Then full name is addition. So is the string concatenation of first name and last name and with a space. Then can print out his full name Ada space Lovelace. And adding white space to strings with tabs or new lines. So space tabs and end of line symbols are called white spaces. So you can print \t means tab, add a tab space before text. Then you can print also with \n new line, \n is a new line. And you can combine \n and \t. So this is for the concatenation. Now we can print Python, then print \t Python. So there are tab space. Also print with a new line. The language Python, C, JavaScript can also print with a new line and a tab space. New line and a tab space. Stripping white spaces. So favorite language is Python with a space. Then favorite language R strip will right side white space removed temporarily. And favorite language L strip will remove white space at the left side. Favorite language dot strip will remove white space at both sides. So favorite language Python, the space, then can print out. You see a space here. And if we use R strip, then no space here now. But fifth language has not been changed, so R strip is temporarily remove this space. So to remove the white space from the string permanently, you have to store the stripped value back into the variable. So this is favorite language with a string after this, with a space after this string. You can use R strip but assign back to this string variable. So create again favorite language with a string, the right side. Then we R strip this space and assign back to this variable. Then we show this favorite language again. Now string has been removed permanently. You can add, subtract, multiply, and divide numbers in Python. And 3 double star double asterisk 2 means exponents. So 3 square. And 10% symbol 3 means modulo. So returns the remainder of division. 3 exponent 2 9 age 23 and avoiding type errors with the str function. So age is 23. Next, if we create a string variable called message equals happy plus age plus at birthday, then it will have error because Python not allowed you to add numeric variable with string directly, so you have to transform this numeric variable to the type string before adding together. So now message happy plus strh and plus best birthday. Then we can print a message happy 23rd birthday. A list is a collection of items in a particular order. In Python, square brackets indicate a list, and individual elements in the list are separated by commas. So we can create a list called bicycles with 4 different types as the elements of this list. So we create another list called number list with 5 numbers in the brackets. So this is a string type list, and this is a numeric list. Create a list issue this list and create a bicycle list. Can print out this bicycle list for bicycles. And accessing elements in a list, you can access any element in a list by telling Python the position or index of the item desired. For example, we can print the first bicycle in this list. And you can also use the string method on any element in your list. So we can get the title form of the first bicycle. You can print first bicycle in the list. Select. Can also print first bicycle's title form in the list. The T is capitalized. And note that index in the list starts at 0, not 1. And Python considers the first item in a list to be at a position 0, not position 1. The second item in a list has an index of 1. So if we print bicycle bracket 1, then the second item will be pulled out. And if we write print bicycles 3 in the bracket, then the fourth item will get out. So we can print the second bicycle and print the fourth bicycle. And we can also access items from the end side. So -1 means the last item in a list. -2, the second item from the end of the list, and so on. So we can print the last bicycle. And also print the second item from the end of the list. Using individual values from a list, you can use individual values from a list just as you would any other variable. For example, you can use concatenation to create a message based on a value from a list. So for example, we can get out the first bicycle and using its title form, then this item concatenated with this string and this string. We create a message with concatenation of string and the bicycle's first element with the title form and plus symbol. Then we print out this message. So this message is my first bicycle with a track. Most lists you create will be dynamic, meaning you will build a list and then add and remove elements from it as your program runs its course. To change an element, use the name of the list followed by the index of the element you want to change, and then provide the new value you want that item to have. For example, this is original list with 4 car brands, and we can change the first element of this list to another value. So this is a list with 4 cars. Print. Then we can set the first value to Ducati, and we print again. Now the first value has been changed. And we can also add elements to a list. Python provides several ways to add new data to existing lists. We can append elements to the end of a list. So this is the original list for the motorcycle. And we can use append function. So motorcycle dot append Ducati. So the Ducati is added to the end of the list. Create this list with 3 motorcycles. 3 motorcycles now. Then we can append Ducati to the end of the list. So now the list has 4 cars now, with Ducati at the last position. You can start with an empty list and then add items to the list using a series of append statements. So we can also create an empty list first with 2 brackets. Then motorcycles append Honda, append Yamaha, and append Suzuki. Create first an empty list. Then we can append 3 motorcycles. We show this list again. So now the list motorcycle has 3 cars now. And you can also insert elements into a list. So you can add a new element at any position in a list by using the insert method. You do this by specifying the index of the new element and the value of the new item. So this is a list, and we can insert the first position, a new motorcycle here. So this is a list with 3 motorcycles. Can insert Ducati to the position 0, first position, and we show this motorcycle. Now Ducati is the first motorcycle and the other 3 motorcycles from the original list. And we can also remove elements from a list. You can remove an item according to its position in the list or according to its value. So removing an item according to its position, you can use the del statement if you know the position of the item you want to remove from a list. So this is a list with 3 motorcycles. We can remove the first motorcycle, the second item, the list with 3 motorcycles. 3 motorcycles now. Then we'll del first motorcycle. Show again. Now only the 2 motorcycles left in the list. Can also create 3 motorcycles now. The motorcycle has 3 motorcycles in the list now. We can delete the second motorcycle this time. We show again this list. Only 2 left. A second Yamaha has been removed. You can use pop method to remove an item. Sometimes you will want to use the value of an item after you have removed it from a list. So the pop method removes the last item in a list, but it lets you work with that item after removing it. So this is a list with 3 motorcycles. So we can use pop method to remove the last one of this list. Then put this removed item in this object. So we can print this object later. So this is a list with 3 motorcycles. Then we can use the pop method. Remove the last one of this motorcycle list. Then print again this motorcycles list. Now 2 left. The last one, Suzuki, has been removed. And we can also print this popped motorcycle. Suzuki, that's correct. and popping items from any position in a list. You can actually use pop to remove an item in a list at any position by including the index of the item you want to remove in parentheses. So this is the list with 3 motorcycles. So we can pop 0. So the first item is removed from the original list and stored in variable called first owned. Create this motorcycle list again. So we pop the first one. Then we can print the first motorcycle I owned was a. This is the title. This message is the string concatenated with this popped value with a title form. So when you want to remove from a list, if you know the value of the item you want to remove, you can use the remove method. So this is a list with 4 motorcycles. So if we want to remove the item with this value, so we can use motorcycle.remove Ducati. So Ducati is removed, but note the remove method deletes only the first occurrence of the value you specify. So if there is a possibility the value appears more than once in the list, you will need to use a loop to determine if all occurrences of the value have been removed. So this is a motorcycle list with 4 motorcycles. Then we can remove Ducati using remove function. And print again. Now Ducati has been removed. Sometimes you will want to preserve the original order of your list, and other times you will want to change the order. Python provides a number of different ways to organize your lists depending on the situation. Sorting a list permanently with the sort method. So this is a list with 4 cars. Then you can use cars.sort. Then the order of the elements are sorted in the list. So we create a list. So the order of the elements in the cars, like now, you can use sort. We print again. So now the elements are sorted alphabetically in the list. And you can also sort this list in reverse alphabetical order by passing the argument reverse equals true to the sort method. So you can use sort reverse true. This is a car list with 4 motorcycles. You can sort reverse true. Then print again. So now the elements in the list has been sorted alphabetically with a reverse order. So sorting a list temporarily with the sorted function. The sorted function lets you display your list in a particular order but doesn't affect the actual order of the list. So this is a list of 4 motorcycles. You can use sorted cars. So it will show the list in a sorted order. But if you print this car again, the order has not been sorted. It has the original order. We'll create again this list for motorcycle. So this is the original order. Okay, play again. So here is the original list. Print with the sorted function. So this is the sorted list alphabetically. Okay, again, print. Here is the original list again. We'll choose. So the original order in the list has not been changed. We can also print the sorted cars in the reverse order. So this is the reverse alphabetical list if we use sorted. So printing a list in reverse order. So just to reverse the original order of a list. This may not be the alphabetical order. So just to reverse the original order of the list, you can use a reverse method. So this is the original list. If we use cast reverse and print a cast, then the order of the elements are reversed. So the last one will be printed first. So the reverse method changes the order of a list permanently, but you can revert to the original order anytime by applying reverse to the same list a second time. So we print. This is the. Okay, we create again this motorcycle list. This is the original order, and we use cars dot reverse, then print again, then order of elements are reversed in the list. Okay, finding the length of a list. You can quickly find the length of a list by using the len function. So we can use len cars and it will return the number 4. So note that Python counts the items in a list starting with 1, not from 0. So this is the list for cars with 4 elements. We use len cars. It will be 4. Looping allows you to take the same action or set of actions with every item in a list. So when you want to do the same action with every item in a list, you can use Python's for loop. Let's say we have a list of magicians' names, and we want to print out each name in the list. A for loop will let Python to handle this task easily. So in the for loop, Python pulls a name from the list magicians and store it in the variable magician. Then print the name that was just stored in magician. Python then repeats this operation for each name in the list. So this is a list of magicians with 3 magicians. Then we can write 4 magicians in magicians. So magicians is a list. In the for loop, for magician will take each element from the magicians, then store in this variable called magician. Then inside the for loop, we print each magician until there's no magician left in this list. So where the no more values are in the list, Python moves on to the next line in the program after the for loop. So this is the for loop. We create a list called magicians with 3 magicians. Then we can write 4 magician, print magician. So each magician has been printed out. It is helpful to choose a meaningful name that represents a single item from the list. For example, here is a good way to start a for loop for a list of cats, a list of dogs, and a general list of items. We can write, for example, for cat in cats, for dog in dogs, or for item in list of items. And using singular and plural names can help you identify whether a section of code is working with a single element from the list or entire lists. Doing more work within a for loop. So every indented line following the line for magician in magicians is considered inside the loop, and each indented line is executed once for every value in the list. So for example, this is a magician list. we can write for loop from the for magician in magicians. Then these two lines indented considered inside the for loop. So we can write print magicians title form. That was a great trick. And print I can't wait to see your next trick. Then magician's title name. Then a new line. Then after this for loop finished, then we can print a single message. But this statement not considered inside the loop. So any lines of code after the loop that are not indented are executed for once without repetition. We create a magicians list again. Then a for loop with two print lines included in the for loop. Run this. So for each element, each magician in list, we share two messages. So Alice, that was a great trick. I can't wait to see your next trick, Alice. And David, that was a great trick. I can't wait to see your next trick, David, and so on. Then after the for loop has been finished to run, then we can print one message. So this message, this print statement is not considered in the for loop. So print only once. Lists are ideal for storing sets of numbers, and Python provides a number of tools to help you work efficiently with lists of numbers. So we can use the range function. Python's range function makes it easy to generate a series of numbers. For example, you can use the range function to print a series of numbers like this. You can write a for loop, the for value in range 1 to 5. Can print a value. The result will print 1, 2, 3, 4. The range 1 to 5 will print a number from 1 to 4. Then for each value of this 1 to 4 will print out. So although this code looks like it should print the numbers from 1 to 5, it doesn't print the number 5. So in this example, range prints only the numbers 1 through 4. This is the result of off by 1 behavior you will see often in Python and many other programming languages. So if you want to print the numbers from 1 to 5, you would use range 1, 6. So for value in range 1, 6, print value. Can print out for value in range 1 to 5, print value. So 1, 2, 3, 4 has been printed out. Use range to make a list of numbers. If you want to make a list of numbers, you can convert the results of range directly into a list using the list function. So for example, we can create a list called numbers, and the value is 1 to 5. Then next we can print numbers. We create a list called numbers. Then print these numbers. So it's a list 1 to 5. And we can also use the range function to tell Python to skip numbers in a given range. For example, it is how we would list the even numbers between 1 and 10. We can write even numbers is a list, create is a list, and the value is from 2 to 11, not including 11, and with a gap of 2. So the result will be 2, 4, 6, 8, 10. So even numbers is a list in the range 2 to 11 with a gap of 2. Then we print out this list. This list has 5 elements. And you can create almost any set of numbers you want to using the range function. For example, consider how you might make a list of the first 10 square numbers. So we start with empty list, then write a for loop. So for each value in the range 1 to 11, not including 11, then we write calculate the square of this value, then assign to square variable. Then in the list of squares, we append this square, and so on. Then when the for loop is finished, we print out this squares list. So we start with an empty list called squares, then we tell Python to loop through each value from 1 to 10 using the range function. And inside the loop, the current value is raised to the second power and stored in the variable square. Then each new value of square is appended to the list squares. So start with the empty list called squares. The for loop for each value in the range 1 to 11, calculate the square of this value and append to the squares list. Then the loop finished, we can print out this list. So the value is 10 numbers, and each value is the square of the value in the range 1 to 11. And to write this code more concisely, you can omit the temporary variable square and append each new variable value directly to the list. So we can also start with a squares list, empty list, then write a for loop with only one statement. So for value in range 1 to 11, we can calculate this square of this value, then directly append to this squares list. Then the for loop finished, then print out this squares list. Start with empty list squares, then for loop for each value in the range 1 to 11, calculate the square of this value, then append to the squares list. Then print out this list. The result is the same with 10 numbers, and each of numbers is the square of each value in range 1 to 11. A list comprehension allows you to generate this same list in just one line of code. A list comprehension combines the for loop and the creation of new elements into one line, and automatically appends each new element. The following example builds the same list of square numbers you saw in previous lectures, but uses a list comprehension. So we can write squares is list, and inside the bracket we write value asterisk 2, then space, then it's like a for loop for value in range 1 to 11. Then we can print out this squares list. The list comprehension begins with a bracket and the descriptor name for the list, such as squares. Next, open a set of square brackets and define the expression for the values you want to store in the new list. In this example, the expression is value square of this value, which raises the value to the second power. Then write a for loop to generate the numbers you want to feed into the expression and close the square brackets. Notice that no colon is used at the end of the for statement in list comprehension. So we can create this list to use list comprehension. Then print out this list. Okay, so 10 numbers, and each number is squares of each number in the range of 1 to 11. You can also work with a specific group of items in a list, which Python calls a slice. To make a slice, you specify the index of the first and the last elements you want to work with. As with the range function, Python stops one item before the second index you specify. So the following example involves a list of players on a team. So this is a list with 5 players, and we can print players bracket 0 to 3, then it will return the first 3 elements. So the code prints a slice of this list, which includes just the first 3 players. So players is a list with 5 players, then can print the first 3 players. And you can generate any subset of a list. For example, if you want the second, third, and fourth items in a list, you would start the slice at index 1 and end at index 4. So 4 not included. Then it will return the second, third, and fourth element. So from the index from 1 to 3. So the second, third, and fourth elements will be returned. So we print the second, third, and fourth elements. And if you omit the first index in a slice, Python automatically starts your slice at the beginning of this list. So if you just write column 4, then it will return the first 4 elements. So we return the first 4 elements with column 4. And a similar syntax works if you want a slice that includes the end of a list. For example, if you want all items from the third item through the last item, you can start with index 2 and omit the second index in the bracket. So we can just write players 2 column. Then it will return all items from the third item and through the end of the list. We print players 2 column, return from the second to the last items in the list. The negative index returns an element a certain distance from the end of a list. So therefore, you can output any slice from the end of a list. So, for example, we can write players bracket -3, then column. Then it will return the last 3 players. So it will return the last 3 players with negative index. And the looping through a slice. You can also use a slice in a for loop if you want a loop through a subset of the elements in a list. In the next example, we loop through the first 3 players and print their names. For example, you can write for player in players, the slice with column to 3, then from the first to the third element of this list. Then for each element of these 3 elements, we can print each element's title for. So players 5 elements, print. So here are the first 3 players on my team. Then we can use a for loop for the slice of a list. So the first 3 elements played. And copy a list. To copy a list, you can make a slice that includes the entire original list by omitting the first index and the second index. So we just use a bracket and a column inside the bracket to copy all the elements of the list. Now this tells Python to make a slice that starts at the first item and ends with the last item, and producing a copy of the entire list. For example, imagine we have a list of our favorite foods and want to make a separate list of foods that a friend likes. This friend likes everything in our list so far, so we can create the list by copying ours. So this is my foods list, and we can also create a friend's foods list with using the bracket or column. So the list of my friend's foods have the same items of my foods list. So my foods list pizza, carrot cake. Then we can create my friends foods list. Then we print out. So my favorite foods are this one, these three. Then my friends favorite food list. Also these three items lists. To prove that we actually have two separate lists, we will add a new food to each list and show that each list keeps track of the appropriate person's favorite foods. So in the My Foods list, we append cannoli, and in the My Friends Foods list, we append ice cream. Then we print out to see. The My Foods append a new food, and My Friends Foods also append a different food. Then we print to see my favorite foods. So this one is appended to in the My Favorite Foods. And this one appended to the My Friend's Favorite Foods. So which means these two lists are independent, separate lists. If we had simply set My Friend's Foods equal to My Foods, we will not produce two separate lists. So for example, this is My Food list, and we just use equal. So My Friend's Foods list is equal to My Foods list. Then we append two different items to each list, and in this form, if to connect the two lists, then append item in one list will also do for the other. We will see. So for My Foods list, create first with three items. Then we just use equal to assign the same value to My Friends Foods list. Then we append two items to these two lists. Then we print out My Foods list again. Now you can see these two items have been appended in the My Foods list. We also print My Friends Foods. Also, these two items have been added, which means if we use equal sign to assign My Foods to My Friends Foods, they are just reference to the same object. They are not copy, not independent object. So if you append one item in one of the two objects, and this will also happen for the other one. Sometimes we want to create a list of items that cannot change. Tuples allow you to do just that. Python refers to values that cannot change as immutable, and an immutable list is called a tuple. A tuple looks just like a list, except you use parentheses instead of square brackets. And once you define a tuple, you can access individual elements by using each item's index, just as you would for a list. For example, if we have a rectangle that should always be a certain size, we can ensure that its size doesn't change by putting the dimensions into a tuple. So we define the tuple dimensions using parentheses instead of square brackets. Then print each element in the tuple individually, using the same syntax we have been using to access elements in a list. So this is a tuple with two elements. We use parentheses to create a tuple. Then if we want to get the first elements, we just can use this tuple with a bracket 0. This form is same as the list, and this can get the second elements of this tuple. We create a tuple. Then we print out the first element and print out the second element of this tuple. And let's see what happens if you try to change one of the items in the tuple. So if we set the first element to 250 and Python will raise an error. We create this tuple first. Then we try to assign a new, change the value of one element. Then type error tuple object does not support item assignment. And the looping through all values in a tuple. You can loop over all the values in a tuple using a for loop, just as you did with a list. So this is a tuple. We can also use a for loop for dimension in dimensions, then print each element. Create a tuple, then we print a message, and we print each element of the tuple using a for loop. So two elements printed out. So writing over a tuple, although you cannot modify a tuple, you can assign a new value to a variable that holds a tuple. So if we want to change our dimensions, we could redefine the entire tuple. So you can, this is original tuple. This is the new tuple we defined. So if you want to change the value, because you cannot change the element by element, so you can define the tuple again with the new value. You can define the entire tuple again with the new value you want. So we create this tuple again with the new value. Then we print out, then using a for loop to print this tuple out. Conditional tests. At the heart of every if statement is an expression that can be evaluated as true or false, and is called a conditional test. Python uses the values true and false to decide whether the code in an if statement should be executed. So if a conditional test evaluates to true, Python executes the code following the if statement. If the test evaluates to false, Python ignores the code following the if statement. A simple example of conditional tests. The following example shows how if tests let you respond to special situations correctly. Imagine you have a list of cars and you want to print out the name of each car. Car names are proper names, so the names of most cars should be printed in title case. However, the value BMW should be printed in all uppercase. Following code loops through a list of car names and looks for the value BMW. Whenever the value is BMW, it is printed in uppercase instead of title case. So this is a car list with 4 cars inside, and we write a for loop. So for car in cars, if this car equals BMW, then we print out this car's uppercase. Else, so if the car is not BMW, we run statement inside the else, then print this car with the title for. So we create car list, then write a for loop to print each car's name either in title form or in uppercase. So if the car is BMW, then print out in uppercase. So you can see Audi, Subaru, Toyota all in title case, but BMW is in uppercase 4. So checking for equality. Most conditional tests compare the current value of a variable to a specific value of interest. The simplest conditional test checks whether the value of a variable is equal to the value of interest. So if the value is BMW, then we check car equals BMW, then get true. And if the value is Audi, if we check car if equals BMW, then we'll get false. So we assign the value BMW to car, then we use double equal to check if its value is BMW. you'll get the value result true. And if we assign the odd value to car, then we check again if the car's value is BMW, then you will get false. And ignoring case when checking for equality. The testing for equality is case sensitive in Python. For example, two values with different capitalization are not considered equal. If the car is Audi with title form, but we check car's value is Audi, we'll get a false. So if case matters, this behavior is advantageous. But if case doesn't matter and instead you just want to test the value of a variable, you can convert the variable's value to lowercase before doing the comparison. So we again assign the value Audi with a title form to car. Then we check the condition if the value is equal to Audi with lowercase. But before we run this equal sign, double equal, we add car.lower to transform the car's case to lower before we do the condition test. Notice that the lower function doesn't change the value that was originally stored in car. So the car's case is still Audi. And this lower is just a temporary transform this value to lowercase to do conditional tests. So we see car's value is Audi with title form. Then we check its value equals to lowercase Audi to get false. And we set again, for example, car's value is Audi, but we use lower function before doing the conditional test to get true now. The checking for inequality. So when you want to determine whether two values are not equal, you can combine an exclamation point and an equal sign. So this means not equal. So we will store a requested pizza topping in a variable and then print a message if the person did not order anchovies. So this is request a topping called mushroom, this value. So if request a topping not equal to anchovy, then we'll print holded anchovies. So request a topping is mushroom. So we check if this topping not equal to anchovy, we'll print holded anchovies. So this message printed out because this value is mushroom, and we test if this value not equal to anchovy. This test will get true. Will get true, then this statement will be run in the for loop, in the if statement. And the numerical comparisons. So testing numerical values is pretty straightforward. For example, the following code checks whether a person is 18 years old. So if the person is 18 years old, then you test numerically if the age equals 18. You get a true result. You can also test to see if two numbers are not equal. So for example, the following code prints a message if the given answer is not correct. So answer is 17. So we test if answer not equal to 42. Then we print a message. This is not the correct answer. Please try again. So age is 18. Then we test age. If age is 18 equals 18, the result is true. The answer is 17. Then we test if answer not equal to 42, then we show the message because answer is not equal to 42. The message is printed out. And the numerical comparisons, you can include various mathematical comparisons in your conditional statement as well, such as less than or equal to, greater than, and greater than or equal to. So age is 19, for example, we can run these tests. So each of the above mathematical comparisons can be used as part of an if statement, which can help you detect the exact conditions of interest. So age is 19. Then we can test if age less than 21. We can also run if age is less than or equal to 21, or if the age is larger than 21, we get false. If the age is larger than or equal to 21, we'll get the false. And you can use AND to check multiple conditions. To check whether two conditions are both true simultaneously, you can use the keyword AND to combine the two conditional tests. If each test passes, the overall expression evaluates to true. If either test fails or if both tests fail, the expression evaluates to false. For example, you can check whether two people are both over 21 using the following tests. So these two people has age 22 and 18. We can test if this age larger than equal to 21 and this one also older than 21. The result will be false because one is not larger than or equal to 21. But if we change the second one to 22, then we test again, then it will be true because both are older than 21. To write concisely, you can also add parentheses here, so it will be more clear. So we assign to age to person, then test if both are older than 21, then it will be false. And we assign new value to 22 for the second person. Then we test again, then it will be true. And you can also use the keyword OR, allows you to check multiple conditions as well, but it passes when either or both of the individual tests passes. So an OR expression fails only when both individual tests fail. So let's consider two ages again, but this time we will look for only one person to be over 21. So these two persons, 21, 22, 18 years old, then we test if one of the person is older than 21, the result will be true. And if we assign the first person to 18 also, then we test again, then the result will be false because none of the two people are older than 21 now. So we will set these two persons' age to 22, 18, then test if using auto test if one of the at least one is older than 21, get the result true. But if we set the first person also to 18 years old, then test again if at least one is older than 21, we'll get the false. And checking whether a value is in a list. So sometimes it's important to check whether a list contains a certain value before taking an action. So to find out whether a particular value is already in a list, you can use the keyword in. So let's consider some code you might write for a pizzeria. We will make a list of toppings a customer has requested for pizza, and then check whether certain toppings are in a list. So this is a requested topping with 3 elements, a list. Then we will run the conditional tests. Mushrooms in requested toppings. This is true because mushroom in. But if we run the pepperoni in requested toppings, we'll get false because this list does not contain pepperoni. The requested topping is a list called pizzeria. Then we run the conditional test. Mushroom in requested topping, get the true in results. If we run pepperoni in requested topping, the result is false. And you can also check whether a value is not in a list. So similarly, you might want to know if a value does not appear in a list. You can use the keyword not in this situation. For example, consider a list of users who are banned from commenting in a forum. You can check whether a user has been banned before allowing that person to submit a comment. So this is a list for the banned user with 3 people. So another user called Mary. So if user not in banned user will print user's title form, you can post a response if you wish. So because this Mary, user's value is Mary not in this list. So this conditional test will get the true. So this message will be printed out. So we create a list for the banned user, and we create a value. Object user is Mary. Then we run this conditional test. If she's not in banned user, then it's true because Mary is not in the banned user. So the print out message, Mary, you can post a response if you wish. A simple if statement. The simplest kind of if statement has one test and one action. We can write if, for example, the conditional test to do something. This is the typical form. So if the conditional test evaluates to true, Python executes the code following the if statement. If the test evaluates to false, Python ignores the code following the if statement. So let's say we have a variable representing a person's age, and we want to know if that person is old enough to vote. So the following code tests whether the person can vote. So assign 19 to this age variable. So this if test if age is older than 18, then the message you are old enough to vote will be printed out. And indentation plays the same role in if statement as it did in a for loop. So all indented lines after an if statement will be executed if the test passes, and the entire block of indented lines will be ignored if the test does not pass. So you can assign age is 19. We can test this. Because it's older than 18, so these 2 statements are run. So you can have as many lines of code as you want in block following the if statement. So let's add another line of output if the person is old enough to vote, so asking if the individual has registered to vote yet. So these 2 messages will be printed out. And if else statement. And if else block is similar to a simple if statement, but the else statement allows you to define an action or set of actions that are executed when a conditional test fails. So we will display the same message we had previously if the person is old enough to vote, but this time we will add a message for anyone who is not old enough to vote. So if we assign 17 to the age, then test if age is 18, is larger older than 18, we will print these 2 messages. But if this test fails, so we will run the else statement. So age is 17. Then we test if age is older than 18, then print this message. Else, if this test is fail, then we will print these 2 messages. So because age is 17, not older than 18, then these 2 messages are printed out. Sorry, you are too young to vote, and please register to vote as soon as you turn 18. And the if and else chain. Often you will need to test more than 2 possible situations. And to evaluate this, you can use Python's if else syntax. Python executes only one block in an if-elif-else chain. It runs each conditional test in order until one passes. So when a test passes, the code following that test is executed and Python skips the rest of the tests. The following code tests for the age group of a person and then prints an admission price message. So for example, age is 12. Then we run if age is younger than 4, then print this message. But this message, if this is fail, then Python will test this conditional test. If it is younger than 18 but older than 4. If this passes, gets a true result, then this message will be run. Then the if test, then the statement after the if test will be run. So if both of these conditional tests fails, then Python will run this message. We see age is 12. We'll test using if, elif, and else. The admission is 5 now because 12 is not younger than 4. Then this gets false. Then Python will test the next. Next will be true because younger than 18. So the statement inside the elif will be run. Then Python will finish this if statement, if, elif, else statement. And you can omitting the else block. Python does not require an else block at the end of an if-elif chain. Sometimes an entire block is useful. Sometimes it is clearer to use an additional if statement that catches the specific condition of interest. So for example, age is 12 again, then we can run if conditional tests, then elif another one, then elif another one, then elif another one. So we do not use else here. We just use very specific conditional test for each age group. So we see age is 12. Then we use a multiple if-elif tests. So in this if-elif test, price has been assigned one of each value. Then next we print out this value. You see your admission cost is 5. So age 12 for this group, price 5, because not younger than 4 but younger than 18. And the else block is a catch-all statement. It matches any condition that wasn't matched by a specific if or elif test, and that can sometimes include invalid or even malicious data. So if you have a specific final condition you are testing for, consider using a final elif block and omit the else block. This is what we have seen in this code. You can do some interesting work when you combine lists and if statements. You can watch for special values that need to be treated differently than other values in the list. You can manage change conditions efficiently, such as the availability of certain items in a restaurant throughout a shift. You can also begin to prove that your code works as you expect it to in all possible situations. So checking for special items. So let's continue with the pizzeria example. The pizzeria displays a message whenever a topping is added to your pizza as it is being made. The code for this action can be written very efficiently by making a list of toppings the customer has requested and using a loop to announce each topping as it is added to the pizza. So this is a request a topping list with 3 items. Then we can write a for loop for request topping in request toppings for each element of this list. Then we print adding this request topping. So you can create a list called request toppings. Then you can write for loop for each request topping in request toppings, print add this request topping. So it's very clear: add mushroom, add green peppers, add extra cheese. Then last one, outside of for loop will print a final message. The job finished. But what if the pizzeria runs out of green peppers, and if statement inside the for loop can handle this situation properly? So this is request topping, and in the for loop we can test using if statement. So if request topping equals green peppers, then a message, sorry, we are out of green peppers right now, will be printed out. Otherwise, if this test is a fail, which means if the request topping is not equal to green peppers, then the message adding this request topping will be printed out. So create a request topping again. Then this for loop. In the for loop, we use an if statement to test if it is a green pepper. So the message is like this. So adding mushroom, and for the green peppers, the message will be like, sorry, we are out of green peppers right now. And for the extra cheese will be printed like adding extra cheese. So this is the last message of the for loop. And checking that a list is not empty. Sometimes it's useful to check whether a list is empty before running a for loop. So as an example, let's check whether the list of request topping is empty before building the pizza. If the list is empty, we will prompt the user and make sure they want a plain pizza. If the list is not empty, we will build the pizza just as we did in the previous examples. So we first create an empty list to request toppings. So next we will run if request toppings, which means if request topping has at least one element and not empty, then it will run the for loop. Else, if request topping is empty, we will run another loop, another message. So when the name of a list is used in an if statement, Python returns true if the list contains at least one item. An empty list will evaluate to true to this conditional test. So here we create an empty list for request topping. Then we will run if-else statement. So if request topping is not empty, we will run this for loop. But if it is empty, then this test will fail. Then we run the else statement. So the else statement is run in this case now. Using multiple lists. What if a customer actually wants French fries on their pizza? You can use lists and if statement to make sure your input makes sense before you act on it. So let's watch out for unusual topping requests before we build a pizza. And the following example defines two lists. The first is a list of available toppings at the pizzeria, and the second is the list of toppings that the user has requested. And this time, each item in request toppings is checked against the list of available toppings before it's added to the pizza. So the code will look like this. Available toppings is a list created, and request toppings is another list which created for the request toppings from the customer. Then we will write a for loop. Then For each request topic in the request toppings, we will check if this request topic in this available toppings list. So if these tests get true, then we print add this request topic. Otherwise, if this request topic item is not in available toppings list, then we will run another message. We ask customer, say, sorry, we don't have these toppings. So we run create two lists. One is available toppings and one is request toppings. Then we write a for loop for each request toppings. Then test if this one is in available toppings. If it is true, then we print this message. If it is not true, then we run the else statement. So you can see the mushroom is in available topping list. So we're adding mushrooms. The same for the extra cheese, but for the French fries in the request topping, the message, sorry, we don't have French fries, will be run out. A dictionary in Python is a collection of key-value pairs, so each key is connected to a value, and you can use a key to access the value associated with that key. A key's value can be a number, a string, a list, or even another dictionary. In fact, you can use any object that you can create in Python as a value in a dictionary. In Python, a dictionary is wrapped in braces, with a series of key-value pairs inside the braces. So this is a dictionary with two key-value pairs, and the key is color and points, and the value is green and 5. Accessing values in a dictionary. To get the value associated with the key, give the name of the dictionary and then place the key inside a set of square brackets as shown here. So we can access the value of key color. So this will print out the value of color. And similarly, this will print out the value of points in this dictionary. So this dictionary with two key-value pairs, so we can get the points value of this dictionary and assign to new points. Next, we can print out these new points with a message. So alien 0 is a dictionary with two key-value pairs, and we can print out the value of this dictionary's color. Its color is green. And we can print out the value of points. Points is 5. We can create this dictionary again. And we can get out the value of points and assign to this variable called new points. Then we can print out a message using these new points. So you just earned 5 points. So you can add new key-value pairs to a dictionary. To add a new key-value pairs, you would give the name of the dictionary followed by the new key in square brackets along with the new value. So let's add 2 new pieces of information to the alien 0 dictionary. The alien's X and Y coordinates. So this is the original dictionary has 2 key-value pairs. Then we can add a new key-value pair called X position equals 0 and Y position equals 25. So this is the dictionary with 2 key-value pairs. And print out this dictionary, 2 key-value pairs. Then we add another 2 key-value pairs. We print out again. Now the dictionary has 4 key-value pairs, color, points, X position, and Y position, and their values. Notice that the order of the key value pairs does not match the order in which we added them. So Python doesn't care about the order in which you store each key value pairs in a dictionary. It cares only about the connection between each key and its value. And you can start with an empty dictionary. It's sometimes convenient or even necessary to start with an empty dictionary and then add each new item to it. To start filling an empty dictionary, you can define a dictionary with an empty set of braces and then add each key value pairs on its own line. So we can start with an empty dictionary with 2 braces. Then we add 1 key value pairs using alien0, brackets color equals green, and points equals 5. So add these 2 key value pairs into this dictionary. We start with an empty dictionary. Then we add these 2 key value pairs into a dictionary. Then print out again. Now the dictionary has 2 key value pairs. Can modify values in a dictionary. To modify a value in a dictionary, give the name of the dictionary with the key in square brackets and then the new value you want associated with that key. So for example, consider an alien that changes from green to yellow as a game process progress. So we create a dictionary with only 1 key value pair, color is green. Then we can modify the value of this key color to yellow. So we create first key value pair green in this dictionary, and we print out the alien's color. The alien is green now. Then we modify the color to yellow in this dictionary. And we can print out again. The alien is now yellow now. And you can set dictionary with, for example, for x position, y position, and a speed medium. Can print original position for this alien x position. So position is 0 now, original. Then we can move the alien to the right. So if alien 0 speed is slow, x increment is 1. And else if speed is medium, then increment to 2, and else increment to 3. So because x speed is medium now, so the increment is 2. And we can also we can run this test first. So x increment will be assigned with a true value now. Then we can modify the position x position with current position plus x increment. So we run this to modify the value of x position. So print new x position. Now we'll see new position 2 because have increment with true value to the x position. And we can also remove key value pairs. So when you no longer need a piece of information that is stored in a dictionary, you can use the del statement to completely remove a key value pair. All del needs is the name of the dictionary and the keys that you want to remove. For example, let's remove the key points from the alien0 dictionary along with its value. So this is a dictionary with 2 key value pairs. Then we can remove the points, the key value pairs with the points. Use del alien0 points in brackets. So we can create these key value pairs dictionary first. 2 key. So print. So there are 2 key value pairs in this dictionary. Then we remove 1 key value pairs points has been removed. We show again this dictionary now has only color key value pair. Because a dictionary can contain large amounts of data, Python lets you loop through a dictionary. You can loop through all of a dictionary's key value pairs, through its keys, or through its values. So looping through all key value pairs, to do so, you could loop through the dictionary using a for loop to write a for loop for a dictionary. So let's consider a new dictionary designed to store information about a user on a website. The following dictionary will store one person's username, first name, and last name. So this is a dictionary called user, and will store username Fermi, first name Enrico, and the last name Fermi. Then we can write a for loop for key value in user this dictionary's items attribute. So this username items attribute will return the key value pairs. Then for each key value pair, we will print key its value and value its value. So you create names for the two variables that will hold the key and the value in each key value pair. You can choose any names you want for these two variables. So you can choose any name for these two variables. The second half of the for statement includes the name of the dictionary followed by the method items, which returns a list of key value pairs. The for loop then stores each of these pairs in the two variables provided. So we can create dictionary for the user. Then we can write a for loop, and in the user zeros items, then we print out this information. So all the key value pairs in this dictionary are printed out. The username value, first name value, last name value. Another example of looping through all key value pairs, so we look at a dictionary of a favorite programming language of a number of people. So favorite language is a dictionary. Then the key is people's name, and the value are favorite languages of those people. Then we can write for loop. We'll create two variables called name language for name language in these dictionaries items. Then we can print names title form, concatenate with a message, and then concatenate with languages title form. So favorite language is a dictionary. Then a for loop will print out information for each person's favorite language. So Yan's favorite language is Python, Sarah's favorite language is C, and so on. So looping through all the keys in a dictionary. So you can use the keys method. It's useful when you don't need to work with all of the values in a dictionary. So let's loop through the favorite language dictionary and print the names of everyone who took the poll. So this is the same dictionary as before. Then we can write also for name, create one variable called name in this dictionary's keys attribute. So then can print out each name's title form. So this is a dictionary. Then a for loop in dictionary's keys attribute. Then only the keys and the people's name are printed out. So looping through the keys is actually the default behavior when looping through a dictionary. So the following two codes would have exactly the same meaning. We can write for name in favorite languages. Do not add any methods after this dictionary. Or we can write for name in favorite languages dot keys. These two statements will get the same result. You can choose to use the keys method explicitly if it makes your code easier to read, or you can omit it if you wish. And you can access the value associated with each key you care about inside the loop by using the current keys. So let's print a message to a couple of friends about the languages they choose. So we will loop through the names in the dictionary as we did previously, but when a name matches one of our friends, we will display a message about their favorite language. So this is the code. So we create same dictionary as before. Then we have friends, a list, 2 people of our friends. Then write a large for loop for name in favorite language to keys. So this name represents each name in this dictionary. Then print this name's title form first. Next, we write an if conditional test. So if this name in friends is this list. So if one of these keys is in this list, then we will print another message, hi, the name's title form, and a message, I see your favorite language is your favorite language's value, which language is title form. So we show this. Create this dictionary first. Then we create another list called friends with 2 items. Next, write a for loop to print out each people in the favorite languages list first. Then, if this person matches in this